Another parameters for the two-port network is the combination of Z and Y, because sometimes also the Z and Y parameters of a two-port network do not always exist or does not represent a specific network. So the third set of parameters is the combination, somewhat combination of the two. We call it the hybrid parameters. So for a hybrid parameters, the dependent variables will be, it's a hybrid, it's a combination. So instead of just V voltage or just current, it's a combination of the voltage and the current. So we have V1 as a independent variable, while the dependent variable, or while the independent variable or I1 and V2. So this will be I2. So these are the dependent variables. So V1 will be equal to a certain parameter called H11. Then you multiply that with I1 plus a certain parameter H12, multiply it by V2, then H21 I1 plus H22 V2. So in matrix form, so these are our equations that we'll be using to represent this hybrid parameter. So in matrix form, so our input variables or our dependent variables are V1 and I2. Then we have our parameters or coefficients H11, H12, H21, and H22. Then our independent variables or I1 and V2. So this parameter here are called the H parameters. So this is a hybrid parameter. It contains a dependent variable of a voltage and a current. Now, how do we calculate those values, those parameters, those H11, H12, and H22? So the parameters can be determined by these formulas. For H11 will be just equal to V1 over I1. So take note of this. If you look at the equation, this is a voltage equation. So therefore, these two terms must also be voltages. So if you look at the first term, the H11 times I1 is a current, a unit is ampere. So in order to make that a voltage, I need to multiply something to that ampere to become a volt. And what should I multiply to that ampere to become a volt? You should multiply it by ohm. So ohm times ampere will become a voltage volt. So we can take note that H11 is actually a impedance value. It's ohms. Its unit should be ohms. While the second term, if you look at the second term, you already have a voltage V2 on the term. So I don't need anything multiplied by that so that it will not change the unit. It still be volts. So therefore, this H12 here must be unitless for it to be a volt. So it should be unitless. Multiplied by a voltage is still a volt. Unlike the first term, which is a current, I1 is a current, so you need to multiply that by the ohms to become a volt or voltage. In the second equation, so this is a current term, a current equation. So this is already a current, so this must be unitless for it to be a current or ampere. While the other one, this is a voltage, volt. So in order to make that a ampere, the unit for current, I need to divide it by ohms, because by Ohm's law, I is equal to V over R or V over Z. But here, I'm not dividing, I'm multiplying by H. So the inverse of that impedance is just admittance. So the unit of this one must be in Siemens. Why? Because Siemens is 1 over ohm. So that if I multiply that by volt divided by ohm is still the current ampere. So it makes sense in the equation. If you look at the parameters, our parameters now has different unit. There are the H21 and H12 must be unitless. H11 must be in ohms and H22 must be in Siemens. Unlike the previous parameters, the previous parameters, they all have the same units. So let's go back to H11. So to solve for H11, it's just V1 over I1. I use V1 over I1 because I know that H11, the unit for H11 must be ohms. So to solve that, it's just an impedance. So I just need to divide the voltage and the current. Z is equal to V over I. So it must be voltage in the numerator and current in the denominator. Then I will make something zero, just like before, and the parameter or the variable that I'll be making zero will be the V2, the voltage in the output. That's H11. So for H21, this time H21, I know H21, the unit for H21 must be unitless. It must be unitless. So what does this mean? This means that my ratio should have the same unit for me to have a unitless value. Unlike the first parameter H11, it's a different unit. It's voltage and current will be equal to ohms, which is the unit for H11. But the unit for H21 is unitless, so I need to divide two parameters that are of the same unit. So here for H21, I'll be dividing I2 and I1. It must be the same parameter, the same unit parameter. So here, I2 and I1 have the same unit, which is current in ampere. Then, again, your voltage must be equal to 0, V2. That's H21. For H12, so this time we'll be equating the first or the input voltage, or instead of voltage this time, because this is hybrid, we'll be making the current be equal to 0. I1, it's the opposite. So H12, this will be, again, it's a unitless. So here, in H21, I divided current. So in H12, I'll be dividing the voltage this time. So V1 divided by V2. And I will make the current I1 be equal to 0. I will make the current I1, the input current, be equal to 0, or it's an open circuit input. Then for H22, this will be, it's not unitless. H22 is not unitless. The unit is actually in Siemens. So here, to come up with the Siemens, I just need to reverse the formula for the impedance, which is V over I. I'll just make it I over B. I2 divided by V2, so that the output will be Siemens in the unit for admittance. Then I'll make I1 still be equal to 0. So these are the ways to solve for the H parameters. So it is much complicated compared to the first two, because it's hybrid. It's the combination of the two. And as before, there are also names for these parameters. H11 is called, because V2, this means we are short circuiting something. So H11 is called and it's in the input because it's H11. 1 means the input. H11 is called the short circuit input, and it's an impedance because the unit is ohms. While H12 and H21, these are unitless, meaning they are gains. We call them gains. For H12, it's an open circuit. H12, because I1 is equal to 0, it's an open circuit, and this is called the reverse gain. Open circuit reverse gain, because that's the gain in the output. While H21, it's not an open circuit, because H21 we make V2 equal 0, so that's mean we are short circuiting the output. So this is short circuit also, but instead of reverse, this is a forward gain. This is a forward gain because we're looking at the input because the output is a short circuit. Then for H22, we call this one. So H22, the unit is Siemens. So this is the admittance and it's in the output. And it should be open circuit because I1 is equal to 0. So this is open circuit output admittance instead of impedance because the unit of H22 is in Siemens. So these are the parameters for H parameters or the hybrid parameters. But there is also other parameters related to this one. They call it the G parameter or simply the inverse hybrid. There is something they call it the inverse hybrid parameter. So this is similar with the H breed or the simply hybrid parameter. The only difference is it is the dependent variables are interchanged. So instead of the first one here, the first equation we solve for V1, but in this one, instead of V1, the first equation will be in terms of I1. The second equation will be in terms of V2. So it's just the interchange. It's the inverse actually of the hybrid parameter. And the variable that we use is G. Or to be consistent, I'll be using capital G. G here. So G11 multiplied by V1 plus G12 multiplied by I2 because we already interchanged our variables. And this will be G21 V1 plus G22 I2. So in matrix forms, so these are our equations. In matrix form, so our dependent variables are I1 and V2 instead of V1 and I2. And our coefficients are the G parameters, G11, G12, G21, and G22. Then our independent variables are V1 and I2. So this is called the G parameters or the inverse hybrid parameters. And to solve for those parameters, we just interchange this here. So instead of V2 in the left side, we'll make that the I2, while in the right side we'll make it the I or the V1. So to solve for G11, so G11 is equal to, again, but if you look at the units here, this is current I and this is voltage. So to make that one a current, you multiply that, you must divide that by Z. So therefore, the unit for this one must be in Siemens. While this one is already in current, so this must be unitless. And this must be unitless also because this is a voltage and this is a current. So in order for that to become a voltage, you multiply it by a Z or ohms. So the unit for G11 is Siemens. So it's the inverse of the impedance. So it will become I1 divided by V1. Here, we're making V2 be equal to 0. Or I mean I2 because V2 is in the hybrid parameter. We interchange them. So that's G11. For G12, it's unitless. And it must be I1 divided by I2. And this time, the voltage must be equal to 0 in the input. For G21, so it's unitless again. So here is the current, while this one will be the voltage. V2 over V1. It's a voltage gain, and making I2 equal to 0. And lastly, for G22, it's not unitless. It's actually ohms. So we just need to divide the voltage and the current, then making V1 be equal to 0. And again, there are names for this. For G11, we call it the open circuit input admittance. Open circuit input admittance. While G21 is still an open circuit because I2 is equal to 0. open circuit. But this one is a gain, and it's a reverse gain, reverse current gain, or it's not reverse current. It should be forward because this is in the input. Forward current gain, or I mean voltage gain. Sorry, should be voltage gain because it's V2 over V1. Then for G12, it's not open circuit. This should be a short circuit because V1 is equal to 0, and it's a current gain. This should be the current gain. Short circuit, but this time it's in the output, so reversed current gain. And for G22, it's a short circuit also, but it's an impedance. So short circuit in the output impedance. So these are the different parameters for H and G parameters, the hybrid and the inverse hybrid parameters. Now let's take an example for the H-brid parameter. Example. Find the hybrid parameters. Calculate H parameters of the circuit given here. Let's take a T-network circuit. With values 20 ohms, 30 ohms, and 60 ohms. So this is our input side, and we have an output side. So we need to calculate our H parameters for this T network. So to calculate the H parameters, we can find first for H11 and H21. H11 and H21, we can find that if you look at our formula here, we H11 and H21, we make our output voltage be equal to 0. So it means it's a short circuit. We just short circuit our output. And also, we'll be applying a current excitation in the input. Then it will be like this one. So this is the output. So this is V2. That's our minus. And in order that to be equal to 0, we just put a short circuit in that side. So this will be I1. And still we have I2 here. This is 60 ohms. I1, and we have a voltage here. This will be V1. 60, 20, and 30. So to solve for H11, first we need to solve for the V1, because H11 is just equal to its V1 over I1. V1 over I1. So this is just V1 all over I1 when V2 is equal to 0. So we need to calculate for V1 in terms of I1. So here, if you look at the circuit, it's easy to solve for V1 because V2 is short-circuited. So this will become just a 60 and 30 in parallel and in series with 20 ohms. So V1 is just the total voltage and I1 will be just the total current. So to solve for V1, it's just equal to the total current, which is I1 multiplied by the total impedance in the circuit. Total impedance in the circuit is equal to 20 ohms. That's the one in series. Then we add the parallel combination of 30 and 60. 30 times 60 divided by 30 plus 60. Then solving for V1, let me take my calculator here. Then go back. Solve for V1. So 30 or 20 plus 30 times 60 divided by 30 plus 60. That is equal to 40. So V1 will be 40 times I1. So V1 is just 40 times I1. Then we can now calculate H11. H11 will be equal to V1, which is 40 times I1 divided by I1. So cancel that I1. So the answer will be a 40. And the unit for H will be ohms. H11 is in ohms because that is the input short circuit input impedance H11. Next, for V2 is equal to 0, still be used. We can calculate first for H21. H21, that is a unitless, and it should be in terms of the current. So this will be I2 divided by I1, making V2 be equal to 0. So we need to relate I2 and I1. So if you look at the circuit, we can just do the current divider. But observing the circuit again, and just like before, if you look at I1, it's the opposite direction of I2. So this means it should be a negative value. So if I solve I2 in terms of I1 by current divider, CDT, by current divider theorem, solving I2, so I1, I'll put a negative here because they are in opposite direction. Then this will be the opposite resistance, which is 60, divided by 30 plus 60. So this will be equal to 60 divided by 90. That's negative 2/3 of I1. Then I can just simply substitute that in my formula. I2 is negative 2/3. I1, I divided by I1. So the answer will be negative 2/3. And it should have no unit because it's unitless. H21 is unitless. Same true as H12. But for H12 and H22, we'll be making our input because we'll make our current I1 input current to be equal to 0, and to do that we need to open circuit our input side. So if this is the input side, you just make it open circuit. Then we can apply a voltage V2 at the output side. Again, this is 60 ohms, 20 ohms, then we have 30 ohms. So the current here, which is I1, must be equal to 0. This is our voltage V1. Then we have a current here, I2. So this is the circuit that we will be using to solve for H12, because H12, it's unitless again, but this time because I1 is equal to 0, so we'll be using the voltages. There should be V1 divided by V2 when I1 is equal to 0. So we need to relate V2 and V1. So if you look at the circuit again, because there's no current flowing to the 20 ohms, so the voltage across the 60 ohms must be also V1. Must be also V1 because there's no current flowing through the 20 ohm resistor and there's the voltage drop across it. So therefore, it's the same voltage as the terminal and at the 60 ohm resistor. So we can just use the voltage divider to relate these two. The voltage by voltage divider, V1 now by VDT, V1 now will be equal to the total voltage V2. Total voltage V2 multiplied by the voltage that we're solving. It's the 60 ohms, so it should be 60, then divide by 60 plus 30 ohms. And I already solved that. That's 2/3 V2. Then I can now substitute that in our formula. H12 will be equal to V1, which is 2/3 of V2 divided by V2. So we can cancel out V2 and the answer will be 2/3. And there's no unit for that because H12 has no unit. Then finally for H22, so for H22, this is an admittance. It's an admittance because H11 is impedance. And if it's admittance, then therefore current should be in the numerator, I2 divided by V2, making I1 be equal to 0. We still use this formula here. So we relate I2 and V2. So it's easy to solve that because 20 ohms is just an open circuit. So we can disregard that 20 ohms. So it's just a series circuit of 30 and 60. So to solve for I2 or V2 in terms of I2, V2 will be equal to I2 multiplied by the total impedance, which is 30 plus 60. Or simply 90 I2. Then we can just substitute that in our formula. So H22 will be equal to I2 divided by 90 I2. So we cancel that out. So it will become 1 divided by 90. And the unit will be in Siemens. So our final answers now, because we are solving for the H parameters. So the H parameters, so we have already solved them. H11. So we have H11, then H12, H21. H11. Where's H11? It's 40 ohms. H12 is 2/3 and negative 2/3, then 1/90 Siemens. Let me check it again. H12 is 2/3. H12 is 2/3. So it should be H12. It's correct. So therefore, this is our final answer. These are the H parameters for that T network. Okay. So there's still another one remaining parameter that we'll be looking at, the transmission parameters. We'll be discussing that in the next discussion.